Alright, so let's take a look at some applications of linear programming. Next week we're going to look at a different method for actually solving linear programming problems. So for now we want to get comfortable interpreting an application type of setting and how we could build a linear programming problem from that. So we're going to start out with this example right here. In the problem it makes it sound like I actually want you to solve it, but we just want to set this up. So we're just going to set up only. If you want more practice, you can go ahead and try to solve this, but we're going to see that this is going to have too many variables for us to graph, so we want to practice just with setting it up, because this would be difficult to solve using a graph, because there's 4 variables instead of only 2. Okay, so let's see. George eats a meal of steak, potato with butter, salad with dressing, and bread. 1 ounce of each contains the indicated calories, protein, and fat. So we're given how many calories, how many grams of protein, and how many grams of fat are in 1 ounce of each of those items. So he has to consume no more than 900 calories and 30 grams of fat. So this is looking like something I'm going to need for the constraints, right? This is limiting how many calories and how many fat he's going to eat. And what are we trying to maximize or minimize? So how much of each item, so that tells me what my variables need to be, the different types of items. So how much should we eat in order to maximize the protein? Alright, so protein, we're trying to maximize protein. So that tells me how I'm going to set up my objective function. And the question is how much of each item. So my variables have to represent the types of items. So let's start by defining the variables. So let's let x1 is going to be an ounce of salad, because each of our numbers that we've been given is relative to 1 ounce. So x1 will be the ounces of salad. I'm going to let x2 be the ounces of potato. x3 will be the ounces of bread. And x4 will be the ounces of steak. There we go. Okay. So the question told me what I wanted the variables to be. Now, let's go ahead and come up with our objective function. So we want to maximize, and since this is protein, I'm going to go ahead and use P. So maximize protein, and we want an equation that describes how much protein we have in one meal. Well, every ounce of salad contributes 0.5 grams of protein, and every ounce of potato contributes 1 gram of protein, and every ounce of bread contributes 1 gram of protein, and every ounce of steak contributes 9 grams of protein. So if we want to know how much protein we've eaten total, we can use this equation right here. So we want to maximize our protein subject to some constraints. So subject to, and then now we need to come up with the calorie constraints and the fat constraints, because that's what we were limited in the problem. So let's go ahead and do calories first. So to do the protein equation, we basically took this protein column, right? And that became all of our coefficients. So if we want to do calories, we're essentially going to do the same thing with our calorie column. So our total calories are going to be given by 20 calories per ounce of salad, plus 50 calories per ounce of potato, plus 25 calories per ounce of bread, plus 56 calories per ounce of steak. Now all of these calories all together have to be no more than 900 calories. So this must be less than or equal to 900. Now let's do the same thing, but for the fat consumption. So our fat column is the last one. So let's see. We get 1.5 grams of fat for every ounce of salad, 3 grams of fat for every ounce of potato, 2 grams of fat for every ounce of bread, and 5 grams of fat for every ounce of steak. all of the fat added up can be no more than 30 grams, so less than or equal to 30 grams. And let's see, the last thing we need are those non-negative constraints. So we need to make sure that we don't eat negative salad, right, or negative steaks. So we can say x1, x2, x3, and x4 must all be bigger than or equal to 0. And then we're done. We came up with the objective function representing how much protein is being consumed. We have two constraints, one for calories and one for fat. And then we additionally have the non-negative conditions because we can't eat negative ounces of salad or negative ounces of potato. All right, and so we've successfully set up a linear programming problem that represents this situation.